Good morning, everyone. My name is Yashwant. I'm from CSC section. My roll number is 234G1A05Y7. Our topic is prove that C naught is equal to C2 plus C4 plus so on C1 plus C3 plus C3 plus so on is equal to 2 power n minus 1. Subject name Discrete Mathematics and Graph Theory. Subject code 23 Math MATH 07. Prove that C0 plus C2 plus C4 plus so on is equal to C1 plus C3 plus C5 so on is equal to 2n minus 1, 2 power n minus 1. Introduction to the proof. This is presentation aims to prove that the sums of the coefficient of even and odd index terms in the polynomial expansion or expansion are equal. Especially we will demonstrate that C0 plus C2 plus C4 plus so on is equal to C1 plus C3 plus C5 plus so on 2 power n minus 1. Understanding this equality is crucial in combinatory mathematics and polynomial theory. Coefficients term 1, term 2, term 3. X power 5, x power 3 z plus 2x y power 3 plus 2x 2 plus y z square. 5 plus 3 plus 1 is equal to 9. 1 plus 3 is equal to 4. 2 plus 1 plus 2 is equal to 5. Degree is equal to 9. Definitions. Let C0, C1, C2 so on Cn represented the coefficients. Coefficients in the polynomial expansion of 1 plus x power n. Then even indexes coefficients are C0, C2, C4, while the odd index coefficients are C1, C3, C5. The total number of terms in the expansion in plus 1 corresponding to the power of x from 0 to n. Solution C0 plus C1, C1 plus C2, C2 plus C3 so on into Cn minus 1 plus Cn, n plus 1 Cn, n plus 1 C2, n plus 1 C3 so on n plus 1 Cn, n plus 1 factorial by n plus 1 factorial into n plus 1 factorial by 2 factorial n minus 1 factorial so on n plus 1 factorial by n factorial by 1 factorial, n plus 1 factorial power into n factorial, n factorial by 1 factorial, n minus 1 factorial, n factorial by 2 factorial, n minus 2 factorial is so on n factorial by n factorial 0 factorial, n plus 1 factorial n by n factorial, c1 into c2 into c3 so on cn, n plus 1 factorial by n factorial, c0 is equal to c1 into c2 into c3 so on cn. Hence option A is corrected answer. Even and odd coefficients. The sum of even indexes coefficient is denoted as E is equal to C0 plus C4 plus sum. The sum of odd indexing coefficients is denoted as 0 is equal to C1 plus C3 plus C5 plus so on. Therefore, we can write the equation S is equal to E0 plus 0 is equal to 2 power n. Exploring the difference. We can also express the difference between the sum of even odd coefficients by using binomial theorem. We can find E0 is equal to 1 plus 1 n minus 1 plus 1 n is equal to n minus 1 0. This implication that e minus 0 is equal to 2 power n, which is essential in our decision. Evaluation total terms. We notice that when n is even, there are n by 2 plus 1 even coefficients and n by 2 odd coefficients. Conversely, when n is odd, there are n by 2 plus 1 odd coefficients and n by 2 even coefficients. This pattern ensures that the number of coefficients in E and 0 remains balanced around n. Evaluate polynomial. N into 2 minus 12 into plus 3 when x is equal to 4 variables. Solutions. N into 4 whole power 2. 12 into 4 plus 13. 7 into 60. 12 into 4 plus 13. 112 minus 148 plus 13. 64 plus 13. 77. Finalizing the equation, we can combine our previous solutions e plus 0 2 power n and e minus 0 2 power n. By solving these two equations similarly, we can find the values for e and 0. Ultimately, we determine that e is equal to 0 2 power n by 2, leading to our desired conclusion. Concluding the proof. Given e plus 0 2 power n and e minus 0 2 power n, we dedicate the both sum equal 2 power n by 2. From the established relationship, we find e is equal to 0 is equal to n. Hence, we can state that c0 plus c2 plus c4 is so on c1 plus c3 plus c5 plus is equal to 2n minus 1. Summary and implication. This proof illustrates that the relationship between even and odd indexed coefficients in a polynomial expansion, the equal c0 plus c2 plus c4, c1 plus c3 plus c5 open against the further expansion in combinatories. Understanding this relationship can enhance our grasp of mathematical patterns and their applications. Monomial coefficient 3 into x square polynomial 3 into x plus 6x minus 15, first term, second term, third term. Thank you for giving this opportunity. Thank you.